Hello guys, in this video I will be talking about the retrosynthesis of this molecule which is colored in the red. So this is an aromatic compound, contains three substituents, methoxy, NH2 group and chlorine groups. So whenever you are asked to do retrosynthetic, first of all you should do is to recognize the functional groups attached on that molecule. So here, first step, we can see that there is NH2 group, chloro group and methoxy group, and also we are asked to do synthesis starting from methoxybenzene or anisole. So this is our starting material and this is our target molecule. We have to, okay, this is the starting material and this is target molecule. We have to devise a synthetic strategy. We need a method that cuts through it and gives us an easy approach to prepare this molecule. Let's start. The first step would be analysis. This is retrosynthetic arrow, and we can see that we can convert NH2 group into nitro group in this step by doing FGI reduction. How we picked this thing is merely because we know the forward direction. You cannot do retrosynthesis until you know the forward direction. So when you reduce the nitro group, this one, you will get NH2 group. Alright, so the retrosynthetic analysis would be convert this NH2 into nitro. Next step is to remove this chlorine via diazonium salt reaction strategy. That's it, and you put NH2 group there because you diazotize NH2 and then you chlorinate the diazonium salt and you will get chlorobenzene. Next step is to disconnect this nitro group, CN nitration, very straightforward reaction. And in that next step you have to FGI reduction, again similar to the first step. You convert NH2 into NO2. And last step, you remove the nitro group and you are at methoxybenzene. This was the retrosynthetic analysis of this molecule. Now let's have a look on the synthesis. You start with a methoxy, you nitrate it, nitration reaction, then you use H2PDC as a reducing agent to reduce NO2 into NH2, and then you protect this NH2 and nitrate at this position. One thing is important here, you need to remember the directing groups, ortho, meta, para directing groups. So electron donating groups are ortho para directors, like methoxy or NH2. These are ortho para directing. That's why the nitro group will attach at the ortho position of this methoxy. Next step is to remove this protecting group, acetyl group, and there's NH2. And in next group, reduce this NH2 and treat with copper 1 chloride. You will get chlorine on this benzene ring. And in the last step, you reduce using hydrogen and nickel catalyst. Nitro group will be converted into NH2. This was the synthesis of this retrosynthetic analysis. I hope you liked it. If you have any questions or if you want me to make another videos on any topic or any question, please put the comments below in this video and don't forget to subscribe. See you, bye.